All right, hello and welcome to McLean 360. All right, so in this video, I'm going to solve a problem with you to illustrate the concept of stress. Okay, um, in this question, we have two cylindrical rods AB and BC welded together at B, and then they are loaded as shown. But look at it carefully. We've been asked to determine the magnitude of the force or the load P, for which the tensile stress in AB has the same magnitude as the compressive stress in BC. So this question is pretty much straightforward. We need to first of all draw the free body diagram, because without it we cannot find the stress in AB and then BC. But it is important to know that AB undergo tensile stress, whereas BC undergoes compressive stress. So quickly, let me draw the free body diagram. Now, this is what you are going to do. There is a sort of, support reaction here. Therefore, there is this kind of reaction, which the support reaction gives to the rods. All right. Now, we don't know. As it stands now, we don't know P. So think about it this way, that if there was a force, let's say R, which was to be acting here. So this is what I'm trying to say. There is this support reaction here. This support reaction will give some form of R, which is like a support reaction to the rod. To find the value of this, we would sum forces. And so when we sum forces, so let's say we decide to sum forces, every force to this direction is positive, should be 0, right? What do we get? So minus P plus 2 multiplied by 30, that is to say 30 plus 30. And then minus R should be what? 0. Is that right? Now, after getting to this point, what you will do is that you can say that R is actually so R is 60 minus P. So we don't know, but we can say that 60 minus P. So maybe I can take this away and then 60 minus P, which is the same as R. Having done this, I can actually find the load. So let's do it this way. The load which is acting in portion BC, all right? So for the load which is acting in portion BC, think about it this way. To be able to get that, take a section like this, and then the whole of this is actually point C, and then there is this load here which is acting on it, 60 minus P. Now for equilibrium, this compressive force which is acting on BC will be acting in this direction, and then for the purpose of equilibrium, it should also get the same value. So if this was to be PBC, we can clearly say that PBC must be equal to 60 minus P. Why? Because of equilibrium. All right. So in fact, that is PBC. Okay. Now we are done with the load in BC. Then you will come to AB. Now you take a section here. Okay, so we are done with AB. And if you take a section through A and B, you can either use the last part or the entire portion. So maybe let's use the last part here. Okay, so it's going to be something like this. So you have this, and there is P here, and then there is A. So then you decide to take a cut here, all right? And that cut is between A and B. Therefore, for the purpose of equilibrium, we can clearly say that this must also be P, right? This must also be P. Okay, now we are done with this part. But okay, so interestingly, it means that PAB is P, meaning rod AB will experience only P, but rod BC will experience 60 minus P. Okay, now our task is to find that value P, for which the tensile stress in AB will be the same as this compressive stress in BC. So let's start. Stress in AB is going to be load over area of AB. Similarly, stress in BC is going to be load, which is 60 minus P divided by the area of BC. Now, having done this, this is what we are going to do. You know, he said in terms of magnitude, so we are not going to include the negative sign. Please, compressive stress is actually negated, but the question said the magnitude, so we don't need to bother about negating it. All right. So, under what circumstance will this stress be equal to this stress? That is all what we are trying to say. So, first of all, let's solve for the area. Okay, let's solve for the area, and then we will just compare the two. Okay, so for okay, for the first area, what is it going to be? So for area AB, it is going to be, so let's go back. The diameter here is 2. So the area is going to be pi times 2 squared over 4, which is nothing but the area of the cylindrical cross section of AB. And that is what? So pi multiplied by 2 squared divided by 4. And what is that? Oh, that is 5. So 3.142. Okay. So 3.142. All right. And then the area of BC. So the area of BC too, we know, because this is 3. So we just have to replace 2 by 3. And that is what? 3 squared over 4. And what is that? So if I replace this part by 3, then 7.0685. Okay, so let's say 7.07. Okay, so 7.07. In fact, this one is an area, and it's supposed to be in inch squared. Okay. You know, these expressions are actually in kilonewtons. Okay, P and then PBC. Yeah, this one is also in kilonewtons. All right. Now, let's try to equate them. So it's going to be P divided by 3.142 should be equal to 60 minus P, which is multiplying BC, which is 7.07. Okay. Now, so we are almost done. In fact, what is left for us right now is change of subjects. Okay, and I hope that the person watching this video should be able to do this. So let's go straight forward and solve for P. So 7.07p, so I'm trying to cross multiply, will be what? 3.142 multiplied by 60 minus 3.142 multiplied by p. So in other words, 7.07p plus 3.142p must be what? 3.142 multiplied by 60, right? So in effect, p is nothing but 3.142 and then multiply by 60, right? Then you divide it by 7.07 plus 3.142. And what is that? So P is 3.142 multiplied by 60 divided by 7.07 plus 3.142. What is that? So P is 18.46. All right. So 18.46 kilonewtons. Oh, sorry. Kips. In fact, it is oh man. It's actually kilo pound force. All right. All right. So that is it. In fact, this one is supposed to be the same thing. All right. I think the concept is clear. Now, can you solve the second part of the problem? Now, this is what he's trying to say. He says that if we now know, okay, for this part, he says that if we now know that P is 40 kips, all right. So most of us are familiar with the kilonewton, but it's kind of almost the same. So we know. So this time the question is saying that if we know that P is what? 40 kilonewtons, determine the average normal stress at the midsection of rod AB and then BC. All right. So this time around, it's like you have to go back and then you know P, okay, but we don't really have to do anything. All what we have to do is that we know that, so we are at 1.4. So this time around, we know that P is what? 40 kip, right? Since we know P, we can now go straight forward, because don't forget that stress, or the average normal stress in AB, was what? The load over the area. Now, if P, which is the load in AB, is 40, then it's just a straightforward substitution. So 40 divided by what? The area in AB, which was what? 3.142. And what is this? So this is going to give us 40 divided by 3.142. So 12.73. Okay. So this stress is coming from the fact that if we know the exact value, straightforward. Okay. So if we know the exact value, straightforward. Okay. So that is it. And then this time around, we are going to calculate. So KSI. I think you are familiar with what you are doing now. So this one is going to be PBC divided by area BC. But what is PBC? PBC is actually you know, 60 minus P. So if PBC is 60 minus P, then it's going to be 60 minus P, which is 40. Then I'll divide by the area of what? BC. And what is the area of BC? So the area of BC is 7.07. So 7.07. Okay. And if you do this, you are going to get so 60 minus 40, which is 20, divided by 7.07. And what is that? So that is going to give you 2.83. But please, this is stress, and it is actually compressive stress. So you have to bring the negative sign. For the first part of the problem, he was interested in only the magnitude. That is why we didn't bring the negative. So please, you have to be very careful in the strength of materials class. All right. But then that is the problem solved for you. So thank you very much for watching. I hope the concept is clear.